Welcome to lesson number 4 of Colgate VisLab's Maya training sequence. In today's lesson, we're going to go over the basics of lighting in Autodesk Maya. In this lesson, I'll be teaching you about each of the types of lights that Maya offers, how to add each light to your scene and what they're meant for, how to see a rendered visual of your lights, and finally, a few examples of a complete lighting setup. So, let's get right to it. This scene should be familiar to anyone who's seen the previous lessons, with a few additions. This is the house that we worked on previously in our texturing lesson and a few others. So, yeah, or the little pagoda, whatever you really want to call it, just a building. Anyway, as you can see, it's the textured version, and in addition, I've added a surrounding lot and another prop, a light post. So I just added those with the basic modeling skills you guys have been taught, and they're going to help us with the scene. So, first things first, I want to show you guys the individual lights that Maya has to offer. So, once you have lights turned on, which is just to say you have default lighting established, you click the button up top here, and it'll say render the current frame. Now, what that means is that when you click render, it will process the image with all lights, visual effects, textures in their full resolution, and models that are within your camera. And all of these will be processed into one image, or a render. So when I do that, another window is going to come up, and I'll drag it over here as soon as it's done. There we are. Now, as you can see, this is a black window. This is because I've established default lighting, added some example lights, and then removed those lights. So essentially what you have here is a scene that's meant to have lights in it, but currently has none. Well, our first step today is to show you how to add lights. So we have our window here, and I'll just swap to another camera just to get more of a workable space. And as you can see, we have the building and the light post. So the first type of light that Maya has is an ambient light. When you click the ambient light button up top here, you get one on the origin. And this is what an ambient light looks like. It has no scale, and more importantly, it has no distance to it. An ambient light is just a level of light that exists in a scene. I don't often use ambient lights because they are very general, but they may work for you in certain situations. To modify this light, you go to your attribute editor, like all other lights, once you have it open, and select this light. And here you have the name, ambient light shape 1. Let's just call this ambient for scene, using the namespace that we're aware of now. You'll see a sample of the color and intensity in most lights that you'll get from this light. You'll have the type of light it is, and you can change that here if you like. So you can change any light into another type of light as opposed to creating a new one, but this is what it is for now. You have the color that the light is, and clicking on that color will give you a whole mess of colors, a color wheel, a shading box, and your mixing tabs. So additionally, we have the intensity, which is default 1, which is a standard light amount. So when we render it at intensity 1, for example, we get something like this, which is very similar to our shading window or our standard workable window here. And then additionally, but if we increase this, you'll see that our scene can get very bright as a result of that. The intensity bar maxes out at 10 by default. However, a lot of times you'll need to go beyond that, so you can modify that by simply entering any given number. So I'll say 600. And that becomes the new median value in the lights. So you have between 1200 and 0. If you do this, just keep in mind that your scale is going to be different on the slider tab. And also keep in mind that with ambient lights, you probably won't want to change this. You won't want to enter your own value, because if you do that, the scene itself will be very blown out. And there's no reason with ambient lights to do that, as we'll discuss later. As you can see there, you pretty much have all but a white silhouette because the scene is what we call blown out. And by blown out, I mean the lights have completely whitewashed the scene, or color washed the scene, and there's no detail left. So I'm going to lower that again, go back to maybe a nice 4. And as you can see, the ambient light is just providing light throughout the scene. And this is what ambient lights do, by the way. They provide an ambience to the scene. They don't have a direction or an origin, and they don't have the ability to provide you with any particular shadows. It's just light throughout the scene, unless you turn on stuff here. The only way, I should correct myself, the only way that you can apply shadows with an ambient light is if you adjust the ambient shade. The ambient shade essentially takes an ambient light and gives it an origin. And that origin is on the lighting icon that you see here. Right now, the ambient light is only shallowly focused here. If you increase the ambient shade, that'll give it more of a concentrated light at a point, similar to a point light. But in that case, you'd want to use a point light anyway. So for the most part, you could leave this alone. Or even reduce it. So other options for the light include shadow attributes, which you can turn on ray trace shadows. However, when you do that, unless you've tweaked the aforementioned ambient shade, you don't get a lot of shadows to begin with. You just get a weird sort of smearing effect. See there? So the ambient shade you do have some ambient shade, but based on the intensity and based on the quality of the shadows you get, which are very jagged, for the most part you will not want to use shadows with an ambient light. So anyway, that's ambient lights. The object display is just basically, that's the same thing that's on every type of object that you can see in Maya, and just says whether it shows up in the rendering process in various ways. Things like ghosting information, bounding box, you won't need to work with that. Same thing with node behavior. That's just for more node-based composition of textures and shaders and things like that for lights. So for the most part, you won't need that. So where you live is going to be up here with the ambient light. Okay. So if I want to change this and leave this in the scene, you can get something like that. Now I left the shadows on. I'll turn those off. And you see you just get a nice sort of orangish, brownish ambient color to the scene. It's just a base color on which to build. That's an ambient light for you. And I'll leave that in the scene. The next type of light that we're going to work with is called a directional light. A directional light, as you can see here, looks differently from an ambient light. Now, a directional light is, at its purest form, direction without direct source. Directional lights you would use, for example, for sunlight in a scene, an outdoor scene in general that has a specific direction the sunlight is coming from or the light source is coming from. You could use a directional light if you want, in essence, a great unifying light from one direction. So just to show you here, I'm going to change that because it has the same color attribute and intensity attribute as ambient lights. And like that, like ambient lights, you can turn on 2 different types of shadows. And in some cases, you may want shadows with ambient lights, but this is where you turn them on. We will primarily work with ray trace shadows, and I'll get more into that later if you guys have specific questions on that. However, for now, just leave shadows alone and leave them in ray trace shadow form. Don't use depth map shadows. So I've made this a fairly alarming magenta color, and what we're going to do, as you can see here in the icon, is place the light so that it has a direction that way. Basically from this direction towards the ground. So when I render that out, and click our render button up top here again, you see that you get light coming from that direction. It doesn't have a specific point of source. Just like ambient lights, it doesn't have, by default, it does not have a default, or excuse me, by default, it does not have a specific point source. However, it does have a directional source. So as you can see with the shadows here, you've got the light clearly coming from this direction on a slant. If I were to change that, for example, if I were to alter the direction and render it again, this is the re-render button, by the way. It'll just render the same camera again. You see the shadows have changed and the direction of the light has changed. And then for further more clarity, if I change it to red, you can see that that directional light is red. And it does blend with the ambient light that we have already. So I think I'm going to leave that. Just leave it where it is. Maybe increase the intensity by a little bit. Make it 3 instead of 1. And there you can see a slight increase in intensity. Just to compare that, I'm going to hit Save up here. This is the Save button for any render that you've done. And there you can see, if you tab between them, you can see that I have it here. And then if we go to the active render, so let's say we make this really high, like 7 or 7.9. Now that you can see it's much brighter than it was. So I'll turn this back down, maybe to a 2.5. Check it out. And it's in place. So from here, we're going to move on to our next type of light. And that is probably one of the most versatile lights that you can use in Maya, and that's what's called a point light. Now, a point light looks similar to an ambient light. But you can see it's got the little, it's got the little cross-hatching in the center there, in addition to the rays around the circle. So that's how you tell the difference. A point light, unlike an ambient light, has a consistently clear point from which it emanates. Just to show you an example here, I'll just put this along the street, or along the parking lot floor here. I'll alter the color, give it, I don't know, like a lime green, and render. And as you can see, it's emitting from a specific point and touching objects surrounding that point. However, it does not cover the entire scene as an ambient light would do or a directional light would do. It doesn't wash the entire scene because it's limited by the point from which it emanates. So that's a point light for you. Now point lights have, in addition to the other lights, they have color and intensity. They have the ability to change between different light types. And they have something new, which is called decay rate. Now, decay rate is important when tweaking the intensity of your lights, because decay rate for us means the rate at which the light falls off as it moves further away from its origin point. So if I were to, for example, increase the light with no decay and increase the intensity, we would get a pretty far-reaching light. However, and it provides us with shadows and things like that as well. However, if I were to instead add some linear decay, which means, by the way, that the light falls off at an even rate, you would instead get a much dimmer light. That's because the decay has been added where once there was none. You can still see it. However, you have to zoom in, and it makes it a much more subtle light. Now, if I compensate by increasing the intensity of this light to, say, maybe 50 and go beyond, like we were talking about with our sliders, go beyond our original chain, we will get a more intense light. However, you can see that it doesn't spread out as readily. It doesn't. It can't send light as far because we have some decay added. Now, if we want to take it a step further, for quadratic decay, which means that it uses a quadratic equation to fall off, we get a very dim, very subtle light. And if we increase it by another factor, say 500, you get a fairly bright light. However, it at an even greater pace than the linear decay, it falls off pretty quickly. So it's a lot more concentrated in one area, and that's the benefit of using decay. You can make softer and softer lights that only influence a certain area, at least in the terms of point lights. So that's basically the long and short of point lights. Additionally, with point lights and with spotlights, as we'll get to next, you can add what's called light fog. However, I'm gonna put that under the heading of visual effects, and we're not going to get to that in this lesson. So, additionally, with point lights, you can use shadows, and in a lot of cases with point lights, you are going to want to use shadows. So, we have ray trace shadows enabled. And so, for example, if I put this here, give it a linear decay again, and move back to something like 60 intensity. And you can see here that the green light hitting this roof provides this shadow. Now, that's in contrast to the shadow that you're already getting from the directional light that we placed earlier. Now, that can tend to be a problem for scenes, by the way, because if you have multiple significant lights in a scene, you often want to pick one to cast a shadow. Unless you're okay with multiple shadows, and unless it doesn't clutter up your scene, which will be at your discretion and at whoever's managing the project's approval, you can leave multiple shadows if you like. However, oftentimes you want to choose a primary shadow. How you do that is pretty simple. You just, if I don't want shadows on this light, just decheck the box. And now when we do this, you see we're still going to get that shadow here. However, the point light, which is about right here in space, as you can see, is not generating any shadow. Alright, now I'm going to add those shadows back just to give you an idea. Oops, not depth map. Use ray trace. Oh, and by the way, if you ever want to keep track of render progress, it's down here. Or, if you like, you can open up the script editor and see it in percentages. But for the most part, unless it's a very long render, you'll see it down here. So, anyway, so we got that point light in our scene. Now, I want to add the next type of light that we're going to work with, a spotlight. Now this, along with the point light, is going to be probably the most prevalent and most widely used light that you'll see in your scenes. So you can see here that you can scale it up and down, unlike point lights, ambient lights, etc. However, that really doesn't affect the how do I put this? It doesn't affect the region that the light covers, just your ability to see the light working on the scene. Just your ability to manipulate it in 3D space. So we have this light here, and as you can see, it's got a cone angle to it. And within the attributes, you can see that it has color, intensity, decay rate, like point lights, cone angle, penumbra angle, and drop off. So, what are these things? Well, decay, you know of. I'm going to give it some linear decay and give it maybe 30 intensity. Cone angle changes, simply put, the angle of the cone spotlight. You use this if you want a wider angle or a very thin angle. Just to give you examples, this out real quick. All right, you can see down here that angle and the disk that's created by the spotlight. So now if I were to increase the cone angle to give it maybe 114 degrees, it works with degrees, by the way, if that wasn't clear. You can see, well, maybe not quite yet. Let's zoom out a bit. You can see that it gets a very wide cone angle. It actually drifts off the scene a little bit. And the other thing to note is that it does fade off as you get further and further away from the spotlight. That's the decay working on your light that we talked about earlier. So let's give that a zany color. Why not? Like a deep indigo purplish kind of color. We'll jack up the intensity even more. Maybe call it 80, because spotlights often will be the primary light in your scene. Or I should say they're used to light important objects in scenes. And let's decrease the cone angle so that we can see a little bit better. And move it up a little higher in the sky, why not? It's also worth noting that in addition to your various manipulator tools like this, you can use your rotate, you can use translate to get your light around. You can also press T on the keyboard to enable target. Target works great with spotlights because by their very nature you need to aim them. So this gives you a little aiming tool, as you can see here. I'm just going to aim this right at the center of the building. And then I'll take the original spotlight and move it. And you see how the aim stays the same, the focus, but the light position changes. That'll give you a different angle. So now, if we zoom out again and generate another render, there it is. Excuse me. You can see that. All right. Now, to cover these last few attributes, penumbra angle. Penumbra is what you call like a fading of the light along the halo or the edge of the light. You can expand your light to include penumbra, or you can contract your light to include penumbra. So basically, let's swap out of target mode, move this closer to the ground, just to give you a good idea of what this actually does. So with penumbra, I guess let's say without penumbra, a light will look like this. It's a very hard edge, and it's often not what you want unless you're literally modeling a stage and putting a spotlight on the stage, which then by all means. However, oftentimes with a spotlight, you don't want that hard, crisp edge there. And so you'll use penumbra to soften that light's edge. Now, another thing that I did here, by the way, I don't think you've learned this yet, is I rendered a region of my frame. Once you're in the render view and you want to render a region of your frame, all you need to do is click this button here, and it'll render that out. And if you'd like to draw a different one, you just drag and then click that, and it'll render the region versus having to render the whole frame. This is useful especially when you have large scenes that you're working with and you don't want to spend 10, 15 minutes rendering a single frame, as is often the case in the VisLab with our 4K by 4K images. Instead, you'll want to like fix a little detail when you're lighting. Like, oh, say I wonder how it is just on that side wall there. Well, let's fix that. Oh, let's tweak something in the scene here. And then like just fix this part. I just want to see what it looks like here now. That's a rendering region for you. So, I think I'm going to leave that as it is, but that's penumbra. Drop-off is very similar to decay, or decay rate, I should say. Drop-off, when enabled, gives you a lot more of a subtle light, and just causes the light to fall off sooner, very similar to decay, but it's unique to spotlights. You see you have this very subtle, almost like tint haze. Now if you turn the drop off, you're going to get a lot more of a widespread light, and a little more of an intense one at that. So those are the spotlight attributes. Additionally, you have light fog, like point lights, and like point lights, we'll go over that later. You have the two different types of shadows, depth map and ray trace. Ray trace is what we'll be using. And that's about it. And the standard object display, etc. So we have two more lights yet. Our next light that we want to use is what's called an area light. Now an area light is very similar to a spotlight in that it has direction, it has a source, and you can scale it up or down. In this case, however, scaling, especially non-uniform scaling, matters very much to an area light. This is because an area light is actually a shapeable light. Now by default it is a standard 1x1 square, and I've scaled it up already. However, you can alter that. I said you can alter that. Alright, and we're back. Sorry about that, just some technical weirdness going on here. Normally you should be able to alter these with scale. You should be able to scale the object. There we are. Alright, so the problem I had there, in case you ever run into this, is that axis orientation needs to be on object to scale area lights. You can't scale it in world space. So anyway, so what's cool about area lights is that you can scale them. And that changes how they affect the environment. So let's place this here. And you can see a fairly intense light here. It has a shape to it, but it's a little subtle. Let's see if we can make it even more obvious. There we are. So you see you have that light patch there that's generated by the area light. Now, what's cool, as I've said before, is that you can scale these, and you can scale them in non-uniform ways. The result can look something like that. You get more of a bar light. Now, this feature of area lights is really useful. However, it's also very expensive, and by expensive I mean that it adds many seconds to your render time, or milliseconds, depending on the scale. So, just use that sparingly, but know that you can shape these. So if you have like a little nook or cranny that needs lit up well, or you have a very specific area that you want to light, you can use area lights to accomplish that, as opposed to spotlights, which sort of wash an area in a cone. So, now, like most every other light, they have decay, they have intensity, and they have color. So we'll pick another color here. Even go with like a very orange color for this. Okay. So let's make this a nice long ribbon. And there you are. All right. We have one more light to show you guys today, and that is a volume light. Now, you won't use volume lights oftentimes, so I'll just sort of give you the very basics of this. Volume lights are 3D lights in the sense that they are 3D objects that you can place lights in. They begin as a sphere, as you can see here. However, you can alter them into boxes, cylinders, and cones. When you do this, you change the field that the light is generated inside. Additional options for these, color, obviously, intensity, again, obviously. You can change them into other lights, and you can set up a color range for yourself. And additionally, and more importantly, you can choose outward, inward, or down axis. This is a direction for your volume light. Ordinarily, when I'm working, I use inward on volume lights because I want to surround an object with light. Oftentimes I'll use a cylinder, and let's generate an object here. So let's say we have this rectangle, and we want to surround it with light on all sides. Don't mess with shading groups. There we are. Just pump up the light, give it a color, give it a like teal color. And we want to surround that object, so we say volume light direction inward. We have a full 360-degree arc around the object, and we hit render. And you see it generates light on the object. From every angle from the outside in. Additionally, you do get a little bit of a point artifact there, but that's because I placed it a little incorrectly. And you see there we are. You get light coming in from all sides to this object. Now if we were to make it outward, we'd get a bit of a different view. You see that the light for the most part disappears. This is because the light is actually being generated inside this object, from inside out. So if we wanted to see what that looks like, just literally cut off the top of it and have a look inside, and you see that the light is being generated inside. Sometimes I use this to give more of a controlled ambience to rooms, and on occasion I'll use this to another effect, light bulbs. Let's see here. Fill that up again. Modify the material attributes here. You should know this from the texturing demo. We'll assign new material. Give it another Lambert. Give it some transparency. Change the color to white. Increase your ambient color and your incandescence. And you see now that object glows. For more accurate light bulbs, I often use skin shaders for it because it allows light to pass through in a different way. But occasionally, with some fiddling, you can get a pretty nice light bulb out of this. So add a little translucence there, give it a bit of a glow. There you go. Light bulb. Pretty easy stuff. So just know that that's another way you can use volume lights. You can focus them outward from within an object. You can focus them outward from a certain point and just cover things in a scalable region, which, by the way, like area lights, you can scale these in non-uniform ways. So they're really, really versatile. They, by default, are a little bit expensive, like area lights are, because they actually generate light from a lot of different points at once and then give you this shape to control that with. Excuse me. To control that with. So I would use them sparingly, but they are usable. So. There we go. Perfect scene, right? Perfect hodgepodge of various different lights. So that's a basic summary of all the lights that are in Maya. However, I want to show you one more thing, and that's what this scene can look like if lit to a certain objective. Now, oftentimes when you're lighting scenes in Maya, you will actually want to light to a certain objective. In my case, I prefer to light to a time of day, especially with exterior shots, or to set a certain mood. I've prepared a few to show you here. Now this here is what's called a set of display layers. you can create objects, and we'll cover this later, but you can create objects, create a new layer, or select some objects and add them to a layer, and then you can use this tab here to turn them on and off. So speaking of which, this is my first lighting sequence for the scene, and this to me is sort of like a midday / hazy sunset kind of look. I wanted a warm feeling, I wanted a definite in the day kind of look. So there you are. It's pretty simple. I have one light generating a shadow. That would be my directional light here. I have my spotlight illuminating this area here, and another spotlight illuminating this area. So the primary light in the scene is going to be this here. The only other thing I've done to the scene is added a backdrop, which is just a half cylinder, or a half sphere, excuse me, with a ramp shader on it, so that it actually gives us that sunset kind of look. So as you can see there, you have the rendered image. Now, what if I want this to be at night? What if I want this to be sort of hazy and spooky as opposed to being warm? Well, I'm going to save that image. You can see there's the copy of it. And then I'm going to kill this display layer here and add a new one. And the result is a much spookier nighttime scene. Now, the only things I've done are I've removed the backdrop. I've removed all of the other lights. I've added a main spotlight that is sort of an orangish color. I've added a point light that is sort of a greenish, yellowish haze here. And I've replaced the lights that were here, the physical lights, by the way, made out of geometry, with other lights that have a texture on them that glows when exposed to light. So this green light here will cause these to glow brightly as though they are emitting the light. Additionally, I've done the same thing with the top of this light post here. This shader in here glows when exposed to light. So I'm sort of simulating this as the light source for the scene, or the primary light source. And the result is very different from this scene. That's the power of lights in Maya. That's what I'm going to be asking you guys to do on projects as we move forward. And that's what you want to keep in mind, that you can change a scene's mood, you can change what it looks like, you can make it look, a lot of times, very pretty, a lot prettier than just the base model when you add lights and you understand how to use them. So that's a basic summary for lights. We'll get into more detail in later lessons, especially with rendering processes. But for now, that's a basic summary. Enjoy, guys.